Welcome to the K20 Center's Zoom Into Your Career video series. These online career expos give students a way to explore many interesting careers and learn about their career options from volunteer professionals. Vanessa Wynn is a software developer working on banking software for Fidelity National Information Services. She began her career at the K20 Center working on educational video games.
All right. My name is Vanessa Wynn, and I'm a computer programmer and architect. And so I will be talking to you today about programming and how you become a programmer and what that means. So I will start with talking a little bit about myself and my background and how I became a programmer, what programmers do really, why you would want to become a programmer, and how to become a programmer if you're interested in that. And these are some subtopics that I will be going over. All right, so a little bit about me. My name is Vanessa Wynn. I grew up in Norman, Oklahoma, and I went to Norman North High School. It was actually the second year that it opened that long ago. And I did not do AP classes. Actually, I took computer programming classes because I thought it was interesting. There was 2 different computer programming classes they offered at my high school. And I took physics because I thought it was interesting, and trigonometry. So when I was in high school, we only had to have 3 years of math to graduate. But I knew that being interested in programming, I would need to take more math classes. So I took a couple extra math classes in high school. I took trigonometry, and I think the other one was advanced algebra. It was like 1 semester each of those classes. And I actually I was not good at math growing up. So a lot of people say, oh, you must be so good at math. You must be so good at all of these, math problems. No, I was not good at math problems. I was really good at English and writing comprehension. But thankfully, my dad recognized that in me, and he said, no, you should be as good at math as you are at reading and writing. So he worked on math problems with me, and he would write extra math problems for me to do. I was very frustrated. I would cry, but eventually it brought up my skill level of math to the other subjects. So just because you're not good at something, or you feel like that's a skill that's necessary for what you want to do, you can still do it. You just have to work maybe a little harder, but you can still learn it and you can still figure it out. So I then went to college at OU, and I majored in computer science. You can get a minor in math pretty easily with that if you take this one statistics class. And I worked at the K20 Center for a little bit while I was in college as an intern. I worked on a grant that we wrote educational video games for kids in school, like you guys, so that you could have fun learning games to play. We actually wrote them. It was before iPads were really a big thing. And so we wrote them on these like very small tablet type devices that had very little memory and processing power. And but we had a good time, and it was a big learning experience for me, and it was a lot of fun. Then I got hired right out of college for a company called FIS. It's a financial company, so it deals with money, deals with like bank software. So if you think about a bank, they have software that processes payments and checks and the cash and the money flow. And that's what my company does. We write programs that help the banks process money. So that was kind of the evolution of how I got to be where I am today. So what do programmers do really? So programming is the process of creating a set of instructions that tell a computer how to perform a task. So when you really break it down, all you're doing is you are telling a computer what to do. And there are various languages that you use to tell the computer what to do. So I've listed a couple of them here. It may not make any sense to you right away, but if you're interested in programming, these are languages that you may want to learn or, look into learning. These are C++, C#, Java, and Python is how you would say those. So it's just like learning any other language. Like if you learn Spanish or French or German, it's very similar to learning another, a spoken language like that, except for you're learning how to talk to the computer instead of other people. And there's similar rules to learning languages and ways that you say things so that the computer will understand what you want it to do. And each language is a little different. C++, C#, Java, the way that you say those things to the computer is a little different. But in the end, all it compiles down to is a set of instructions to tell the computer what to do. So you may be writing in different languages, but in the end, the computer can figure it out and know what you're trying to say. So what else do programmers do? What are the types of job functions that we have? So oftentimes we talk about writing code, right? So we're writing in these languages. We are telling the computer, we're giving it instructions of what we want it to do. Do we want it to process data, large sets of data? Do we want to do research? So we want to give it a large set of data and, run algorithms on it and run calculations on it? Or do you want to just build a website? Do you want to build a web application where you can have a lot of interaction with users? Do you want to build a video game, right? Do you want to build a phone application? So all of these bullets listed here take programs, take software to run, right? Robots, you have to program the robot to do what you want, right? If you build the robot, using hardware, so you have hinges and you have cameras on it maybe, and you have wheels on it. Well, something has to tell the wheels to go and something has to tell them to stop, right? Or move the arms. So you would use software to tell the robot when to roll and when to stop. You can also program complex pieces of machinery. So if you think about farming equipment or equipment in hospitals or airplanes or cars, all of those pieces of machinery have software that run on them to help them perform their function, right? So airplanes, we can run a lot of calculations while you're trying to fly an airplane to determine how high up are you, are you level with the ground? Are you falling at a fast pace? Are you, and then you can help the pilot determine, do you want to, what is the trajectory? Should you pull up? Should you, how far away from your destination are you? So all of these things require software, and they require programmers to write that software. Programmers often work in teams, but you can work as an individual. So a lot of times you'll be on a team with other people. So you'll be on a team with other developers, other programmers. A developer is a programmer. Or you'll also have a business analyst person or a product owner. And these are all people that maybe don't write code, but they help tell you what your program needs to do. So they help you fill in what we call requirements for what your program needs to accomplish. So a business analyst might come to you and say, hey, Vanessa, I really want you to write this program that will capture an image of my check so I can deposit it to the bank. So I would say, okay, I can do that. I can write that software. And then the product owner would come and say, well, the customer really wants us to support this on a phone and on the computer and on a tablet. So you're like, okay, I can do this. So the business analyst and the product owner often work together to provide a list of requirements of what you need to write. Sometimes you may be a single developer and you work by yourself. You don't work with any other developers or programmers, with the business owner or the customer directly. So maybe it's a smaller job, smaller operation, and you're the only developer, you're the only programmer, and they say, hey, we want to add this to the website. We want to be able to accept credit card payments. And so it's just up to you to add that functionality. Whereas if you're on a team, then you can work together. You can pull pieces apart. Hey, I'm going to do this piece. Oh, okay, you can do that piece. So it's really across the board. You can work in any piece of industry or any industry with either a team or as by yourself. So there's a lot of opportunities there. There's a lot of we call it like breadth, right? So there's a lot of opportunities available. And I'll get into that in a minute. So why would you want to become a programmer? So I don't know how many of you all have seen the movie The Matrix, or maybe you'll see it in a couple of years because you might not be allowed to watch it yet. But it's a great movie, and it's one of the ones that made me want to become a programmer. Very interesting. And a lot of people that I talk to, kids that I talk to, they are interested in becoming a programmer because they want to make video games, which I agree is very cool. Like I said, I did that for the K-20 Center, and we had a lot of fun making video games. But it's very hard work. There's a lot that goes into making video games, and there's a lot of industries out there, like we've talked about, that want programmers as well. So there's actually a lot of reasons besides just video games to become a programmer. One of my favorites is you can create anything you want to. How cool is it that you can build something from nothing, on your computer? You can create whatever you want. And it's like magic to me. I felt like when I was a kid learning how to program, I really enjoyed that. There used to be it was before Facebook, we had something called MySpace, and it was very customizable. So you could make your background shiny, blinky, you could do different fonts, different colors, different pictures, very customizable. And so that's kind of where I started programming on my own, was changing my MySpace background to different colors and images. You can solve interesting problems. So if you like solving problems, if you kind of like that challenge when somebody gives you a problem and you need to figure it out and kind of dissect it, that is what programming is, So someone says, hey, we need this piece of functionality, or they already have a piece of software and it's doing this weird thing. Every time I click this button, this other light flashes and it shouldn't be flashing. Those types of problems you get to dig into and solve. And that can be lots of fun and also very rewarding. And as we kind of talked about a minute ago, every industry needs programmers. So finance, like I'm in, banking, with the banks, all the banks have programmers. They hire programmers, and a lot of programmers. Healthcare is a big industry. Everything, all of the documents and the paperwork for when you are go to the doctor and the hospital, those are all getting put onto computers now. They're all getting digitized. And so they need software to store and retrieve and update all of those documents. Agriculture is another one. So in farming, they've been doing a lot of really cool things with software. They can put little trackers on animals now, and they can get the animal's location and health data to their phone through, using these new pieces of technology and software to track the animals and have a better idea of how your animals are doing. There's also design and retail. So there's a lot of, an example is there's been a lot of websites lately that allow you to, you can sign up for clothes. They send you clothes, and there's a stylist, and they kind of design out these clothes that you may be interested in wearing, and they mail them to you. And if you like them, you keep them and pay for them. And if not, you send them back. So there's a lot of these new websites like this, and kind of these different forms of online retail. And it's a big industry right now that's really, they're hiring programmers to build these websites and build their infrastructure. Also the smart home stuff. So all of the Google, Alexa, all of those devices inside your home that you have now, those all run on software. It's very interesting because there's nothing that you see or a screen that you touch or have a mouse or anything, right? You just talk to it with your voice, and it hears you and understands what you're saying and can respond to you, which is a really neat application, I think, of programming. So it's a different kind of programming. Programmers are paid well. So this information is kind of for a starting programmer, like if you were to just graduate college and try and get a job. This is for the United States in general, and then senior developers, yeah. So $40,000 to $60,000 a year, and then senior developers up to $110,000 a year. So this is really dependent on where you live, what company you work for, what industry you're in, and how much experience you have. So all of those things play into how much money you make. It's a very diverse salary, but in general, programmers are paid well. So for example, finance industry probably pays the best, the higher salaries. If you're in some place like California or Oregon, you will make more money, but you also have to remember it costs more money to live there. If you live in some place, like we're in Oklahoma or in Kansas or Texas, you won't make quite as much money as they do in California. So it really depends. But the great thing about becoming a programmer is you can work anywhere. Everybody is hiring programmers. You can go to Europe, you could go to Australia, you could go to Canada, anywhere, any state is hiring programmers. So it's been pretty stable. It's been pretty good job to find a job whenever you graduate. And it's a lot of fun. I like programming. Okay, how to become a programmer. So you're interested in programming. You want to make video games, or you want to write software for banks, or write software for your favorite website. There's kind of three main paths that people take. You can go to college and get a computer science degree. That's the route that I went. You can go through a technology program. So there's a lot of like Votech schools and 2-year schools that have computer programming courses and programs that you can go through. You just want to be careful when you look at those programs, because some of them will say, IT security. So you want to make sure if programming is what you're interested in, go for, ask, do they teach you how to program? That's just what's important there. And there's also a lot of coding boot camps available online. And some of these are cheaper options to the coding boot camps. You just want to read reviews and see, do they have job placement when you're done? And then there's also what's called open source projects. So open source is whenever a software project is available free at no cost, and you can basically download the code, okay, all the code that's been written for that project, and you can include it in your program if you want to. So there are so many open source projects. A lot of these are, they run all over the place. So it could be a website, web application. It could be for your phone, like a phone app. It could be for your tablet, could be a game. And getting into the open source projects is a good way to also get experience and learn, how to work with others on others' projects and how to become a programmer if you kind of have limited resources for what, if you can't go to college or if you don't want to do the 2-year program. It's a really good way to get into programming as well. I have some resources available here. These are some websites to kind of help you learn if you're interested in learning programming. So StackBlitz is a little advanced, but the code.org and W3 Schools are really great websites to start from to learn. And then Raspberry Pi put on here if you're interested more in kind of robots and hardware side of programming. You might be interested in the Raspberry Pi because it's a very small little tiny computer, and you can hook up other devices and lights and screens and things to it, and you can write code for the Raspberry Pi and run it. And it's a fun project as well. I also have some references for the salary and for the industries that we talked about earlier. If you're interested in kind of the prospective jobs, this is kind of more about jobs. And that is all I had for you guys today on computer programming. I'm happy to answer any questions that you have.
Okay, thank you so much, Vanessa. That was such a great presentation and a lot of really helpful information, the resources, the coding. So we definitely encourage all students watching this, check out those coding apps. That is a really great way to get practice now. So thank you so much for that, Vanessa. We do have a few questions we would like to ask. Generally, these are really come up really often with students. And you mentioned it earlier. I love how you talked about how math wasn't initially your best subject, but you worked really hard at it. And that is what's really important. We always want to emphasize that for students. Like, it's not about how smart you are, but it's really about how hard you work. So thinking of that, our students are in the 8th and 9th grade this year. Do you have any recommendations for students? Like, what should they focus on while they're in high school to help them prepare for a career in computer programming if they're interested?
Yeah, like I said, I was fortunate enough that my high school had 2 programming classes that actually got me started, and because we didn't have the websites like they do now to start with. So I would recommend, if your high school has programming classes available or any kind of computer related, even if it's word processing or even if it's just typing, that can all help you get familiar with the computer in general, and that can help kind of lay a good foundation, as well as a lot of, like I said, things have changed so much in just the short amount of time. I've been out of school for 13 years. It's changed so much since then. And there's so many great websites and resources now, like the websites that I had listed here. So I would just recommend definitely, take the math classes. If it's optional, go for it. Even if it's hard, just try your best to do the extra math classes if they're available to you, and the programming classes if they're available to you.
Okay, thank you. You shared, why you wanted to become a programmer. I love The Matrix. That is definitely a great movie. But just thinking about like your daily work, requirements and responsibilities, like what is the hardest part of your job?
Oh, that's a great question. And this is probably true for a lot of careers and not just programming, but one of the hardest things for me is communication. Being able to communicate what you're trying to convey to other people often causes the most amount of problems for me. I feel like a lot of times when you're working with other programmers, they kind of have a different frame set in their mind. Like, they kind of think a little differently. They're more we talked about, kind of more problem solving type of people, really analytical type people. And so you kind of have to communicate with people like that a little differently. You just have to learn how to do that. And that can be challenging sometimes, especially when you're having to communicate with business people. So you have to talk to business related people that don't know programming at all. You know, you could say, oh, well, there's a bug on line 49. This, you know, should be a 0 and it's a 1. But the business people don't always understand that. But then when you're talking to developers, they may not understand why you want this certain button to be green and only 10 pixels tall or something. So the communication is really the biggest point of conflict. I feel like it's the hardest thing to work through in the day.
Awesome, thank you. So based on those two questions, kind of building on those, are there any skill sets that might surprise students that you use regularly? Say you were just talking about communication, which is different from that math skill set, right? So are there other skills that maybe students haven't thought about that they need for this career?
Yeah, for sure. So with programming, what's really cool is, like we talked about, you can go into any industry, but you can also apply different skill sets on top of programming. You can layer it. So I personally really enjoy working on user interfaces, and that is the part of the program or website that you interact with as a user, the buttons, the way controls are laid out, the input fields and everything. And so that takes a lot of that kind of artistic side of your brain to see and to, you know, appropriately place the elements so that they look good and that they're usable, versus just going to put these buttons and input fields all over the page randomly wherever I want. And I think that if you do have another skill set, you can often layer that on top of programming. So I've also known other people that were very interested in the medical field, but were very good programmers and liked programming. And so they would go more into research, where they were in medical research, you know, working on vaccines or working on disease, you know, studying diseases, but they were able to use their programming background to solve the problems, you know, trying to solve these problems, coming up with a cure for, you know, cancer, and, you know, trying to come up with vaccines. So that's kind of a broad answer to your question, I'm realizing right now, but you can really apply any skill set that you have on top of programming.
Wonderful, thank you. So next question, what is your favorite part of your job? What do you enjoy the most?
I love I have to say two things. So I really love writing a program. I've been working on it for a long time and trying to get it to work, and it's not working, or it's taken a lot of time, and finally seeing it run and finally seeing it work is very satisfying. I really love that. And I'll do a happy dance or clap my hands. Secondly, I love helping other people with their problems. So I said that I was an architect, and I didn't really talk much about that, but what that means is I get to help other developers write their code, and write their code so that it is better, so that it works better, it runs faster. And I really love helping other people when they have a problem they can't solve, and I can come in and help them solve it, or I can kind of lead them on the path where they can solve the problem themselves. So I really enjoy that as well.
Thank you. That is, it's like when you have like something you want to persist and just keep going at it, like that is really great.
Yes, yeah.
Right. We are reading a book now. They say that's how inventors are. They come to an issue, they ask a question, and then they fail. They ask another question, they fail again, and they just keep asking questions so they get it. So that's really awesome.
Yeah.
Our last question that we had, unless there's anything else you would want to share, is like what you mentioned earlier, like with computer programming, oftentimes it's believed it's connected to being like a game programmer. But are there any other careers that are similar to computer programming? So say a student is interested in this field, are there any other careers in the cluster that they might also be interested in if they like computer programming?
Oh, yeah, that's a good question. So, kind of akin to programming, I touched on it a little bit with the groups development teams, but typically you'll also have, and I should have put this and I can update the presentation before I send it out, but you'll have QA, which is quality analysis or quality assurance, and that is someone who tests the software. So you also have to have that kind of problem solver analytic mindset, but you don't actually always write the code. Sometimes you'll write testing software to test the program, but you're the one that will run through the program and test it to perform all the functions, enter in all the information, and make sure that it works, so that when you give it to your customer or publish it on the web, it all works as expected and you don't get a lot of bad email, bad input back. There's also the business analyst. So that is typically, you would go down kind of a more business path, like in college, you'd probably do more business type degree, but they're the ones that are responsible for shaping kind of what the program will do. So they don't actually write code, they give you a list, kind of, write it out in Word, for example, of what they want the program to do. It needs to accept checks. You need to be able to take pictures. You need to be able to enter an amount. And so it's also analytical, but doesn't require actually writing code. And you get to still help build a product, build the software. And then there are various other type research roles where you don't always write so much code, but you analyze the data. So you'll get this large data set. So for example, I have a friend that works at the National Weather Service, and they receive all this data back from the satellites, and it's kind of raw data. So that means that it's not been messed with or touched or anything. And they have a set of calculations that they run against the data, and they're able to pull it out and build it into charts and graphs so that people like us who don't know anything about weather data can understand what that data means, what that data is saying. So they can say, oh, we have more hurricanes this season than last season based on this data that we've gathered from the satellites. And they can make predictions on that data, right? That's how they make the weather predictions. It's going to rain next week. So sometimes they do a lot of programming, but there are other positions like that that don't require a lot of programming, but you're still analyzing the data.